All right, so angles of rotation is what we're talking about today, and before we start graphing these, you might want a highlighter today or a marker or a colored pen so that you can see the angles that we're making. A few definitions to help us as we go along. The first thing is standard position. So an angle's in standard position when the vertex is at the origin and then you have a ray on the positive x-axis. Do you guys remember what a ray is from geometry? Yeah, how would you describe it? How would you guys describe a ray? Yeah, the one side has the arrow on it, the other side is a point. And then the initial side is the ray on the x-axis. Okay, the terminal side is the ray that is not on the x-axis. Okay, so there's going to be a positive rotation and a negative rotation. So we're going to graph both of those. So have you guys done anything with these before? The initial side, the terminal side, or I was assuming that was new information, but some of you said you may have done this before. Okay, do you need more time for definitions? Alright, and then we're going to start the positive rotation. I'll give this one a second. Alright, so on your positive rotation, we're going to do the initial side first. Okay, so that is going to be on the positive side of the x-axis. Okay, that's what we call the initial side. That's where you start. How many of you are in physics this year? Physics this year? None of you? Are you in chemistry? You doing physics next year?
I don't remember.
So in physics they deal with vectors, and this is also related to vectors. It's also something that you'll do in pre-calculus, and you did a little bit with vectors in geometry as well. So some of these terms may seem familiar. And if not, this is going to lay a good foundation for some of your future classes as well. So if you are graphing an angle and there is a positive rotation, you're going to start at the initial side and it's going to go to the terminal side, and you're going to draw your arrow to show the direction. Okay, you'll also be given a value for theta, that's your angle. Okay, and you will be labeling it. And then we're going to review our angle measures. So you start here at 0 degrees. What degree is at the top? 90 degrees. And then your straight line is 180. Do you guys know what this one is? Yeah. Are you in physics?
No.
Oh.
I do read
Oh, okay. Yeah, so you just add 90, right? Each quadrant is 90, okay? And then a full time around is 360. Aiden, do you remember some of this?
What?
Do you remember some of this? Or no? Oh. Okay, so then the negative is going to be the initial side. And then you can have the same terminal side. So the initial side doesn't change. The terminal side doesn't change. But if it is a negative rotation, you go clockwise. So you start at the initial side, and then you rotate to the terminal side. Okay, and you would have a certain theta value for that. So remember, theta is just our variable for an unknown angle. Okay, theta is our value for an unknown angle. So again, if you start at 0 here, if you're rotating in a negative direction, okay, then this would be negative 90 degrees, negative 180 degrees, negative 270, and then negative 360. Okay, so you have positive rotations and you have negative rotations. So to determine which way you're going to go, you're going to rotate the terminal side, okay, but you always keep the initial side in place. And that means that it's always going to be on the positive x-axis. Okay, and this one is always on the positive side of the x-axis. This is also going to be important as we do the unit circle, which will be next week. Okay, so we're going to be doing a lot of foundations in this section. So we just talked about if you're rotating counterclockwise, that is going to be a positive rotation, okay, like we have up here. Okay, so it's a positive angle. And if you are rotating clockwise, that means you have a negative angle. Okay, and then something that you may have not done before is rotate an angle more than 360 degrees. So they can be rotated more than 360. What it does is it makes a spiral. So we're going to draw an example of that. Okay, so if you are rotating more than 360, you still start at the initial side, okay, and then when you do your theta, we're just going to go 1, we're going to stop there. Okay, so it does look like a seashell. So you have this coil, okay, so you go 1 full rotation and then you keep going around. We're going to be graphing something like that today. Alright, so example 1, we're going to draw an angle with the given measure in standard position. Okay, so they give you the angle. So we're always going to start in standard position, which means we're going to start with the line on the positive axis. Okay, and if you want to use like a marker when you're doing your homework, that's fine. For this part, if you want it to show up, or like a colored pen is fine. Before we put the terminal side on, let's go over the quadrants. Do you guys remember where first quadrant is?
Top right.
Yeah, good. It's the positive one. So positive, positive, positive x, positive y. And then you move counterclockwise. So 2, 3, and 4. So keep that in mind. So if you're trying to graph 320, we already said this was 180, this was 270, okay? You do have to have a close estimation. So we know this is 270, we know this is 360. How are you guys going to decide where to put this? Because you know it's somewhere in quadrant 4. You guys want to try it for a minute? You want to think about it? Each quadrant is how many degrees? 90 degrees. Okay, so if I were to put this right in the middle, what's half of 90? 45. Okay, so 320 degrees is how many degrees from 360? 40, right? So it is going to be pretty close to halfway. We just start here and we're going to rotate around. Okay, and then what you would write is theta equals 320. Okay, and then again, you can just put this for reference. This is how we know where to put this side. Okay? Okay, and then I want you to start thinking about E. Yes? You can think about where you add the 270 to get to 320. Okay, and remember, your terminal side is always here. This is negative, so I'm going to be going clockwise. So let's think about where our negative values are. Negative 90, negative 180, and this is negative 110. So is it going to be closer to the negative 180 or the negative 90? Yeah, how many degrees is negative 110 from negative 90? 20. So we just have to go 20 degrees past this. So draw your arrow and then also do your theta. Okay, so for these, okay, you have to do the arrow, both sides, and then label what your angle is. Okay? And again, we did that by thinking about this as, okay, that's 20 degrees. Right? Alright, now C is 990, which is a very big angle. This one's going to be a spiral because it's more than 360, but we have to find out where it ends up exactly. So we know one full rotation is 360. What if I did another full rotation? What would that be? 720. You guys want to get your calculators out, you can. Okay, and then if I did another full rotation, what would that be? 1080, yeah? Okay, so we know it's less than that. How can I find out what this is before you get to the 1080? Well, remember each quadrant is how many degrees? 90, so just subtract 90, right? So what's 1080 minus 90? 990. Okay, so think about how many rotations you're going to have. So 1 time is 360, 2 times is 720, and then you're going to go to 990. Okay, you might want to watch me do it first, or if you're feeling good about it, that's fine. A couple people last hour, they go, whoa, what, what happened? Okay, so I'll show you how I do this. So remember, it's positive, so we have to go counterclockwise. And I know I'm going to end up here. So my first full time around is going to go 1, that's 360, 2, that's 720, and then I end up here, that's my 990. Okay, so that's your spiral. So it does start to look like a bullseye, or one of those hypnotic spinners, right, as you go forward. right. Good, that's our first part. It's drawing our angles. Now we're going to talk about a special angle relationship called coterminal angles. Okay, and coterminal angles are angles that have the same terminal side. Angles that have the same terminal side, which means they have this side the same, okay? Now, because you can do these rotations where you have multiple rotations in them, there is an infinite amount of coterminal angles. So an infinite amount of coterminal, and I'm going to use my abbreviation for angles. It's the angle symbol with this slash through it. And I put the apostrophe S. No, it's not grammatically correct, but I think it looks funny with it. Okay, so an infinite amount of coterminal angles. Okay, so we're going to do an example along with finding the coterminal angles. So for this one, I'm going to use the example of an angle is 135 degrees. Okay, so if an angle is 135 degrees, I would start graphing just like we did in the last one. I know that 135 is 45 degrees past 90. Okay, so that's going to be right here. We're not going to put that angle part in there because it'll get kind of messy because we're doing a few things. Okay, so this would be 135 degrees. Now, if you were trying to find a coterminal angle and this was 135 degrees, you could also go counterclockwise, and this angle would be coterminal. Okay, so you have this angle to start, this is coterminal. Do you guys know what that angle would be if you start here and end up there? Yeah, it would be negative. Negative 200 and, no, because this is 180, right? And if this is 45, it would be negative 225, right? Okay, so that's going to be how you can find the negative angle. Okay, so a coterminal angle is going to be negative 225. Okay, and then if I wanted to find a positive angle, I could do a rotation. So instead of just the 135, I could start here, and then I could keep going and do a full rotation like this. So all I'm doing is I'm adding what to my original angle? 360, because it's a full rotation, okay? So in order to find out what that is, you would just add it together. Okay, so you would take your original angle, 135, and you would add 360, because that's a full rotation. Or sometimes you'll hear them called a revolution. Okay, so 495 degrees, and then to find the negative 225, I know we looked at this and did it, but you could also just do 135 minus 360, and that's negative 225. Okay, so look what we did. We added 360 and we subtracted 360. So to find coterminal angles, you can use that strategy. You can add or subtract 360 from your given angle. Okay, so that is what we're gonna do. Now you can do that multiple times. So you could keep adding 360 to find other angles, and you could keep subtracting 360. Because remember, there's an infinite amount. So if you wanted to, you can also add and subtract multiples of 360. Okay, and you could do that like plus 360, or what's 360 times 2? 720. So you could also just add or subtract 720 to find coterminal angles. You could do that as well. Okay, really you guys will probably just add 360 twice, okay, with what they're asking you to do here, okay? Alright, so example 2, they're asking you to find the measure of a positive angle and a negative angle that are coterminal with the given. So you have to have one positive and you have to have one negative. And remember, there are an infinite amount. So for A, you have theta is 65 degrees. Okay, so in many cases, to find the positive, you can just add 65 plus 360. Okay, and then 425, that's a positive angle. Okay, and also many times you can take your angle and you can just subtract 360 from it, and that will provide you with a negative coterminal angle. Okay, so very similar to what we did in our example, adding 360 minusing 360. Okay, and then for B, we have theta is 410. So this one's going to be a little bit different. The first part where you're finding the positive, okay, that can be the same, where you take 410 and add 360. Okay, and you get 770, which would be a great positive angle. Okay, now if you were trying to find a negative angle and you did 410 minus 360, what's 410 minus 360? Positive, right? Positive 50. So this would be another positive example. Okay, so you could not use that as your negative. What you have to do for the negative is take 50 and subtract 360, or take the original and subtract 720 of that multiple, okay? And then you would have a negative. So like these would be the two most common positive ones. And again, either one is correct. Okay, there are an infinite amount of both. Alright, and then for C, theta equals 360. So go ahead and find a positive and find a negative for 360. Okay, so Dylan, what'd you get for your positive?
720.
Yeah, good. Anybody write anything besides 720 for the positive one? Okay, and then when you subtracted, if you subtracted 360 minus 360, you get 0. Is that negative? It's not positive or negative, so you have to keep going. Okay, so your negative value should be negative 360. Yep. You could also do negative 720. Okay, so if you add 360, yep, when you subtract you get 0, so you have to subtract 360 again. Okay, so now you have a positive and you have a negative. Okay, do you guys have any questions for me on finding the coterminal angles? Alright, let's talk about reference angles. Okay, so reference angles are going to be really important when we do the unit circles. So today we're doing an intro to them. And we are going to end up connecting some of this back with what we did last week in 10.1. Okay, so reference angles. They are positive, and it's a positive and acute angle. Okay, so a positive, acute, what does acute mean? Less than 90. So a positive acute angle formed by the terminal side of theta and the x-axis. So a positive acute angle formed by the terminal side of the x-axis. Okay, so we're going to do an example here with what you'll see is one of our favorite angles. Okay, so if you have your initial side is here, okay, remember that this is your terminal side. Okay, and then this is the positive side of your x-axis, this is the negative side of your x-axis. So notice this just says of the x-axis, okay? Whatever your angle is, you are going to go to the side that is closer to it. So as an example, we're going to say that theta is 135. Okay, so if theta is 135 degrees, you have to find the shortest distance to the x-axis. Okay, so you either would go from the terminal side to the right side or from the terminal side to the left side. So from the terminal side to the left side, what is the measure of this angle here? 45, because 45 plus 135 would make what? 180. Okay, so this is your reference angle. Okay, and for this particular example, your reference angle would equal 45 degrees. Okay, and then just make sure you label this as your example. Okay, because it's going to change depending on where it is. Okay? So the main things you want to make sure with your reference angle is that it is positive. It'll never be negative. Okay? The other thing is that it's acute, which means it's between 0 and 90. In rare cases, your reference angle will be exactly 90. Okay? In most cases, it'll be between 0 and 90. Okay? Alright, so I'm going to give you an angle, and then we're going to find the reference angle. Okay? Alright, so the first one, let's do 325. 325 degrees. Alright, so go ahead and graph the angle of 325. You always start with your initial side. Okay, and then I want you to graph the 325. We know it's in quadrant 4. But you're going to have to do it so that the reference angle is easier, okay? So will you guys graph the 325 for me? Just like we did on the last page? Can we do that or no? So remember, this is 270, this is 360. So how are you going to decide where to put 325? Yep, is it exactly in between? Yeah, and you can decide how you're thinking about this. One way is from 270 to 325, just think of the distance. What's 325 minus 270? 55. Yeah, so 50, so you can think of it as 55 degrees, or the other way you could think of it is 360 minus 325 is 35. So it is going to have to be a little bit closer here. Okay, so this is where theta is your 325. So no matter which way you thought of it, you either thought of, hey, this is 55, right? You either thought this is 55, or you thought about this is 35, okay? The reference angle always goes from the terminal side to the x-axis. So which one of these is going to the x-axis? The 55 or the 35? 35, so that's your reference angle. And again, it's because it always is going to go to your x-axis. Okay, and one way you could calculate this is to do the 360 minus the 325. That will work in this quadrant, which is quadrant 4. All right, for B, we're going to do negative 105. So theta equals negative 105. So once I know it's negative, I put my negative 90 and my negative 180 here, so I can start thinking, okay, where should I be putting this other side? So from negative 90 to negative 105, how many degrees are in between them? 15. So I would say that that's going to be closer to this side. Okay, so this would be your negative 105. Okay, we talked about the distance here was 15. What I have to find is the reference angle, which is from the terminal side to my x-axis. So how can I find this guy?
180 minus.
You could do 180 minus 105. Yeah, you could also do. Yep, either one would work. Okay, so you know that 15 and this have to add up to 90, right? So it would be 75 degrees. So your reference angle is 75 degrees. Okay, so you could do 90 minus 15. You could ask yourself, what do you add to 15 to get to 75? You could do 180 minus 105. All of those are great strategies. All right, and then the last one, we have 50 degrees. Theta is 50. So what quadrant is 50 degrees in? First quadrant, right? Halfway is 45, so this is just a little bit more than halfway. Okay, so when you're trying to find the reference angle, remember, it's always which direction is the shortest to the x-axis. If I go from here to here, is that going to be an acute angle? No, because it's greater than a quadrant. Each quadrant is 90. It cannot be bigger than a quadrant, okay? Which means your reference angle is this angle, right? Well, what is that angle? 50 degrees. So the first quadrant is special. The first quadrant, the reference angle is equal to theta. That will only happen in the first quadrant. Okay, because all of those are less than 90. Okay, so a good way to think of your reference angle is it's always the shortest distance to what axis? X-axis. Good job. Okay, alright, so now we're going to relate this back to our trig functions. Okay? I don't know why I put formula. There's a bunch of formulas. We're going to write them all here. Okay, so the first thing we're going to do is we're going to draw an angle. Don't call it that. I don't like that. Upward position. Don't call it theta because we're actually going to call theta something different. Okay, but do draw this part. Okay? And then we're going to relate this to what we did last week with sine, cosine, tangent. Okay? So the sine, will you tell the person next to you what the sine is? What over what? Okay, whoever didn't say that first, let the person next to you, or let the person who didn't say it, say the cosine. What's the cosine? Alright, what's the tangent? Alright, what's the reciprocal of sine? Starts with a, yes. Nope. They always start with the opposite ones. Okay, so you have this on your paper, just this angle here, okay? Alright, and then what we're going to do from here is we are going to make a right triangle because the sine, the cosine, and the tangent is right angle trigonometry. Okay, so I want you to just connect this so that now you have a right triangle. Okay, we are going to call this angle theta, which based on what we just did, remember, theta, this angle is the reference angle. Okay, that's going to be important when we do the unit circle as well. Now, this line here is on the x-axis, so we're going to call this x. Okay, anything that's horizontal, that's going to be represented by x coordinates. Anything that's vertical is going to be represented by what? Y. Okay? And then the hypotenuse we're going to call r. And you don't have to worry too much about that now, but it is going to connect back to a radius. Okay? That's why we're calling it r. Alright, so we have these three things. We are going to write out the sine of theta and what that's equal to. So you guys just told your elbow partners, I heard you say the opposite over the hypotenuse. Okay, so Luke, what's the opposite of theta in this case? Yeah, what will be the opposite side of theta? Yes, so we're going to put y on top, and then what's our hypotenuse? R. Okay, so y over r, that's going to be our equation for sine. Okay, the cosine, what are we going to put on the top for this one? X. So that's going to be x over r. Okay, and then Dane, what's the tangent going to be? So do the opposite. What's the opposite side from theta?
Y.
And what's the adjacent side? Yes. Okay, now something that you would see in your textbook is they would say y over x, and they would say that x cannot be 0, because that would make it undefined. Okay, and then the last formula that we're going to need is to find r. So remember, using the Pythagorean theorem, r squared equals x squared plus y squared. Or if you just want to write r is the square root of x squared plus y squared, both of those work. Okay, this would be solving for r by taking the square root of both sides. Okay, so we're going to use that on the back page. Okay, so what we're going to do for these is find the exact value. So exact value means you are going to have no decimals. Okay, it's going to be an exact number, many times with a radical, of the 6 trig functions. What you are given is a point P that's on the terminal side of theta in standard position. Okay, so what we're going to do is we're going to make a drawing to represent where this point is. And to make the drawing, you can just put an XY axis here. And then I don't expect you to put like all the dash marks. We're just going to be labeling this. And what I want you to think about are the quadrants. So this is your X and this is your Y. Okay? If I'm traveling along the X axis and I want to go -6, I start at the origin and then do I go left or right? Left. Okay? Then to go to 9, I'm going to go up. So I want you to just put your point in quadrant 2. Okay? It does not have to be exactly to scale, but you do have to draw in your right triangle. So now you draw your terminal side, which goes towards the origin, and then you are going to draw the other side of your right triangle. Okay, this is your theta value, that is your reference angle, and then what you're going to label is the X, which was -6, and the Y, which is right here, which goes right here. Okay, so you have your X and your Y. Okay? Do you guys know what we're going to do first? Yes, find R, which is going to be the Pythagorean theorem, so we're going to find that hypotenuse. Okay? So -6 squared plus 9 squared equals R squared. 36 plus 81 equals R squared. We will be taking the square root. Okay, and when you do this, do not split this up. You have to add them together first. Okay, it is not the same thing. And you get 117. Now, when you take the square root of that, you're going to get a decimal. Okay? So if you get a decimal, then we have to simplify the radical. So we got to try perfect squares. Do you guys remember the first perfect square that we tried? 4, which is 2 squared, right? Okay, so 2 squared is 4. You try 4. I know 4 is not going into 117. Why? Yeah, it's an odd number. Okay, so after 4 we try 9, which is 3 squared. So 117 divided by 9. Yep, we got it. So if I rewrite this, this becomes 3 root 13. Okay, that is going to be your value of r, that is your hypotenuse. Okay, the rest is very similar to what we did on Friday, okay, when you had to find your trig functions. Okay, so to find the trig functions, I'm going to do the sine of theta equals, and then all you have to do is your y over r. So the opposite over the hypotenuse. Okay? So the opposite in this case is 9. Your hypotenuse is 3 root 13. And remember, when you simplify, 9 divided by 3, okay, is going to be 3 on top, because it's a whole number. 3 over root 13. And then we have to do what here? Yes. Okay, so we have 3 root 13 over 13. Do you guys remember what I recommended, which function to do next? Yes. Because the sine and the cosecant are what? Reciprocals. Yep. So if these are reciprocals, I would just take the simplified one and you do what? Yes, how do you reverse it? Oh, no. No, if it's a reciprocal, what do you do with it? You flip it, yes. So root 13 over 3.
I have a question.
Yep.
If we were trying to find out on my calculator, could we just press second and then like sine? And you get sine from -1, so it's the inverse?
No, that's a different function that we will learn about next week, but that will give you an angle measure. Okay, and then we just find your cosine and your secant, okay? And then go to your tangent, but do the cosine next. Okay, so if you did that, you would have 3 on top over, what would be on the bottom? Oh, 13 over 3, root 13 like that? Yes. And you have to do all this. And then just remember, I recommend you flip it this step just to prevent yourself from doing more work there. Alright, so the cosine, what number is on top when you're doing the cosine? Yeah, so -6 over 3 root 13. Okay, so you guys should have simplified that just like we did this one. 9 over 3 was 3, so -6 over 3 is what? Yep, so -2's on the top, root 13's on the bottom, and then you rationalize. Okay, really we should get so good at rationalizing that you can go right from here to here. So again, okay, the reason why I use this one is because this is simplified. You could also just flip this first step here. Okay, so the secant, you're going to do the reciprocal. Okay, so with the negative, I usually just put the negative in front or apply it to the top. It doesn't matter if you keep it on the bottom, it's normally when you're doing the proper math, you put it as a negative on top or in front. Alright, and then the last one is the tangent, okay, which is your y over x. Okay, so Kaden F, what did you get for that one? Did you do y over x?
Simplified, I got it to 3
Good. Okay, so simplified, you have -3 over 2. Okay, and then with that one, usually the cotangent is Very simple to flip. Okay, so the cotangent is the reciprocal. Okay? Notice that you flip it, but the sign stays the same. Okay? Sine and cosecant, both positive. Cosine and secant, both negative. Tangent and cotangent, both negative. Not a coincidence. I just watched your case. Alright, so I want you to go ahead and do and start with your picture, okay?